hello, Mr. Martin Garner. Martin, who's the Chief Operating Officer at CCS Insight, is going to talk to us about living on the edge, but only as far as IoT is concerned. Thank you.
Thank you very much, Annie, and good morning, everybody. Thank you very much for tuning in for this. So, as Annie says, I lead the research that we do here at CCS Insight in industrial IoT, and I'm also COO of the company. And I'm going to talk today about life on the edge for telcos in IoT. It's the IoT opportunity we're focusing on. Now, just in case you don't know CCS Insight, we're a mid-sized analyst firm active in the telco area and enterprise and consumer technology markets. We do a lot of advisory work for quite a wide range of blue chip companies around the world. So in looking at this talk today, we think edge computing is a fascinating new area, especially for telcos, because it opens up a whole new opportunity for them. And I want to focus on the IoT elements of that. And I want to start by looking at it from a telco point of view, but then flip and look at it from an IoT's customer's point of view. And the aim there is to see what's involved for telcos in trying to address that opportunity. And I want to pull out a few key factors that telcos need to get right if they're to be successful in that, and hopefully leave some time for Q&A at the end. So let's just start with IoT edge computing from a telco point of view. And I want to begin with enterprise 5G as a context, really, for that to go into. Now, we think enterprise 5G is a really good and interesting opportunity, but not until 2025. So we think it's a sort of longer, slower build of an opportunity. As far as we can tell in our forecasting, it's going to be led by adoption in China, and we think they will be much faster in rolling this out than other areas. The good news is that China's adoption will create economies of scale that will benefit other parts of the world and help us to do those implementations slightly more cheaply than we could if we started today. We do think in the Western world there'll be a lot of pilots before 2024, but not much at real scale. And one of the factors that will limit the speed in Europe and other areas is a huge focus on security, and that's security at all layers of the stack, from the devices themselves up through the air interface, through the data transport over the network itself, into the control plane, and security of slices that you might need to connect up to your corporate network to make all of this work. So we are excited about this, but we think it's a longer, slower opportunity. The good news is that there's lots of work we should be doing now to prepare for it as the market starts to build. And I'll look at a little bit of that as we go through. So then zooming in on edge computing as part of this. Now, there are various lead use cases for edge computing or telco edge computing that are widely banded around the area, and I've listed out most of them here. All I want to say with this is that IoT forms a big part of those now, whether that's private networking, on a physical private network or a partition of a public network, whether it's wide area IoT or whether it's parts of what frontline workers do, doesn't really matter. There are lots of good opportunities in there. And the reason we're excited about this is that the 5G network, it's the first time we've had a public wide area network that is genuinely designed to support multiple use cases and different modes of working, including all of the really demanding things that industrials have for setting up their systems. And so we think we can address it really well. And in fact, one of our predictions that we make each year is that private 5G networks look set to be the context in which the fastest innovation on 5G takes place. And that's because those who run a private network won't have to worry about the whole public network. They can get on and do things within their closed environment. And we think they will do that perhaps more quickly than it's possible to do on a public network. So IoT is a big part of the overall telco edge opportunity. But one thing's really, really important to keep in mind, which is that the IoT opportunity is not the same sort of technically and in the way you set it up and the business models as some of the other opportunities. And it's because the drivers are different. And I'm going to attempt to summarize that in this slide. So the first thing is that IoT is all about getting data in to the network and on to the cloud. And this comes up because with IoT, we are already generating truly enormous volumes of data. And really the question is about how to process and manage that in the most efficient way. And simply shipping it all to the cloud just is not the answer. It's too big, too expensive, too slow. So what we need to do instead is a lot of local processing. And by that, I mean real-time decision making. We have, in many of the use cases, very high latency requirements. We may even have time-sensitive networking, time-sensitive computing to deal with. And so the idea is that you basically process whatever you can locally, and you only centralize what you have to. And some of that will, of course, be data. Some of it will be updates to the machine learning models. Some of it will be analytics and so on. But local processing becomes really, really important. And with IoT, the third issue is that we are normally working on a highly distributed architecture, and that's done for very good reasons. It increases resilience. It allows some parts of the system to work offline if the network is down for any reason. It allows us to do over-the-air updates of edge software and security and areas like that. It provides new features like automatic failover. If one device stops working for any reason, the workload can shift automatically to another device and the system does not stop. These become really important in IoT systems, and they're very different from, say, a content delivery network, which has a different architecture. Okay, and so the architecture itself becomes really important, and we'll look at a bit more of that in a moment. So now let's flip over and take a point of view from an IoT customer and see what IoT edge computing looks like for them. The first thing to say before we dive into the detail there is that the industrial IoT market was going really nicely before COVID hit. The supply side had become much better at serving customer needs and packaging up their systems and what have you. And the whole customer community were much more confident in what the use cases were and how to buy systems. And the traditional sort of risk aversion we had seen was starting to fall away, and there was really good growth coming into the market. Post-COVID, what we see is that the needs for IoT systems are in fact stronger than ever. But of course, the economic conditions are more challenging. So here we are in a condition with very, very strong needs for these systems, but we're not expecting a boom in the market because of the economic conditions. We've actually seen that sort of shift come through in our annual IT buyers survey. And I just have, some of the top 10 investment priorities for the next 12 months on this slide here. What we saw was that the green issues here, 2 through 5, have moved up the priority stack, and they are all to do with continuing to operate in a COVID environment where working from home and collaboration and cloud becomes super, super important. And what we've seen is that Internet of Things and edge computing, sadly, is not top of the list for many, many companies at the moment. And we do expect over the coming 12 months that priority will shift back up again, but right now it's not the highest issue. Security, and this is really important, is at the top of the list. It's been there for the last few years in our service, and we're expecting it to continue at the top of the list. So now let's look at edge computing itself. And we see lots and lots of discussion about what is the edge, please define the edge, where is it, what does it look like, and so on. We take a very practical view of this. There's a range of options, and it's all about where to run a specific piece of software or a workload. That could be in a small computer like a surveillance camera. It could be in a gateway that's screwed to the wall in your factory or your warehouse. It could be in somebody's backpack, which they lug around as a frontline worker and so on. It could be in an autonomous vehicle, or what is quite a powerful rack of computing in your on-premises server. So this range, it includes indoors, outdoors, fixed, mobile, small computers to quite large computing stations. And that, as a definition, might sound a little vague, but this is where I want to come back to the architecture involved with IoT. And as we mentioned before, this is normally a software-defined and distributed architecture. It is not normally a centralized architecture. And I think in the telco world, particularly with things like NB-IoT, this view can be a bit challenging, where telcos often see IoT in a more centralized way than their customers do. But this decentralized architecture is now becoming very well understood and is becoming entirely normal in the industrial IoT world. And to illustrate that, I borrowed a picture from Software AG, and that clearly shows that there are devices which represent one type of edge computing. They then describe a thin edge, which in other people's terms is a gateway, then a thick edge, which might be an on-premises or a telco MEC server, and then off we are into the cloud. So there are clearly layers of edge computing and options about where workloads might run. But what I find interesting is that now if you talk to people like AWS or Microsoft or Intel or Dell or Bosch or Siemens or Honeywell, Hitachi, Fujitsu, all of those people, they have a similar picture that they show people. And this architecture is becoming entirely normal. Now, all of those edge devices need to be secured and managed and operated as part of the one system. So now let's take a look at, well, what does that mean for telcos who are starting to address this opportunity? And I want to take several views of this, if you'll allow me. So 3 views, and then we'll get to the Q&A. The first one is that we hear an awful lot of what is basically hype about 5G, about how 5G is going to transform industrial landscape and transform manufacturing and logistics and all sorts of areas. And I just want to use the distributed architecture I've just shown you to illustrate how challenging that is going to be in practice. So here we are with another example of the architecture that I just showed you. And what you'll see is that it's a full stack from the edge device up through the communications, through gateways with their own computing and cloud instances running on them, through on-site networking and on into cloud storage, a bigger, broader data layer, analytics and AI, and other business systems running on top. Now, here's a system. It's installed, it's working in a factory, and it's using the distributed architecture I talked about. There is already in this system an awful lot of wired and possibly wireless communications. There are a lot of different protocols. We're aware of about 35 different flavors of Ethernet that you could use in this system. And so there are many, many options about how you set this up. And those options range from the edge right through the on-premises equipment through into the cloud. Now, what I've done is I've introduced 5G as a communication option. This was meant to happen in a build, but unfortunately that hasn't come through. And what you can see is that if you just put 5G in as another communication option, we really haven't transformed anything. All we've done is add a new protocol and a new communications option into what is already rather a complicated picture. And that on its own doesn't transform anything. It's just another option. But actually so is Wi-Fi 6, and that brings some of the same benefits. And so, here we are moving forwards, but not transforming. Where this does get really interesting is where you can layer some edge computing on top of the 5G. And with the dotted line that I'm showing here, start to simplify whole layers of the stack and consolidate the layers down to a simpler architecture with fewer layers in it. That, if we can get it right, brings a lot of potential benefits to people running these systems and is a really interesting proposition. So the second view is to look at, well, how do we do that in practice? What are some of the issues for telcos in tackling that? First thing is to say that most of the IoT edge will be on-premises computing. It's already happening. It's already quite large scale, and people are doing this within their factories and so on. That set of conditions will set expectations in the addressable market for telcos. And so we think that for IoT customers, as telcos arrive with edge computing, it's not really a separate market. And this is a really, really important point. What it is an alternative supplier, an alternative product option, a technology substitute. And it's a substitute for something they're already doing. And that, that's where their expectations will come from. So in order to be successful, the telcos will need to fit into the customer's IoT architecture easily. Now, we just heard from Carlos Garcia about how the scale of what's involved in updating the telco's own architecture. Now we're adding on the task of fitting into somebody else's architecture as well. I think this is quite a challenging area for the telcos. But there's more, which is that when we start looking at the cloud side, IoT customers will by and large have already made their cloud choices, and that's independent of anything that the telcos do. And so the telcos must collaborate with all of the cloud players in order to serve the IoT opportunity successfully. And one more thing about these customers and their view is that early customers, we think, of the telco IoT edge services will tend to be the larger players, and they will tend to be bigger international companies who have acute needs in these areas. And that international side is really, really important, because what they don't want is a national solution from a national telco and the task of having to replicate that times 20 across the different countries that they operate in. Someone needs to make that complexity go away in order to make this market sort of properly accessible for those companies. Now, there is an exception to all of this, I'm happy to say, which is that if the telcos can package up solutions in IoT and sell those to newer customers who maybe haven't got going on it, then we think there's a much bigger opportunity. And there's a good example I've shown in this picture here, which is a new system from AWS, which they launched just before Christmas, which they called Monitron. Now, you place an order on the AWS site, and tomorrow morning a van draws up and a box is unloaded, and you take out your system, you screw it to the machine that you're worried about, and it monitors vibration and noise and humidity and some other factors like the operation of the machine, feeds all that into a predictive model, and here you have a predictive maintenance system that's ready to go. You don't need to be an expert in machine learning, you don't need to buy all the components, it's just a working system out of the box. If telcos can get to that with some of their IoT systems, using their own edge services, then I think there is a big opportunity for them to address. So I just want to go back in closing this talk off to the issue of how do telcos fit into customers' IoT architectures, because I think here are some of the key questions, if you like, that they need to get right in order to be successful in addressing this opportunity. So as you put together your edge IoT service within your telco, how will customers vet that service for security? What will they actually do, and what information will they have access to satisfy themselves that this is safe to connect up to their network? That's one. Next one is, if they want to put a new device on the network, what do they do as far as your service is concerned to authenticate it and not mess up the security they just validated? Then we move on. So they already have this service running, it's running maybe AWS Greengrass, and now they want to update some of the cloud features maybe Greengrass 2.0, which was also just launched. How do they do that using your service is quite an important question for them. How do they then update device software, some of the analytics and machine learning models? How is that done across their network using your IoT edge as part of the service? And then looking at the resilience, what happens if the network fails? Can the system continue to operate? Can they have automatic failover between devices so that a workload can shift in real time and the whole system carries on working? How does that play out? And then if they want to deploy a new feature across multiple countries using the telco edge side, how does that actually happen in practice? Whose management console do they use to do it? And what do they have to do? And then if they want to add some sort of layers of quality of service to this and use network slices across the network, across multiple countries, how does that work? Because I think that will become quite important fairly quickly. Now, some of these questions are sort of down in the technical weeds, but honestly, that's what IoT system architects worry about. And all of these highlight the interaction between the cloud players and the telco world. And that interaction we think is central to how this area will play out in the future. So we do think there are good opportunities for telco edge in IoT if the telcos can work well with multiple cloud players, can focus on making complexity go away, and can invest in very packaged sort of work out of the box systems to serve IoT opportunities. So I'm going to stop there. Thank you very much for tuning in and listening in, and hopefully there's time for a little bit of Q&A. Annie.
Thanks very much, Martin. Interesting. So this is a question I was thinking of as well. One of our attendees is asking, how do you see telcos working with machine control companies like Rockwell, Honeywell, Siemens, etc., which you highlighted as a particularly area?
Yeah, exactly. And I think that's truly a great question because all of those are global companies. And so somehow the telcos have to get those companies to accept their telco edge products as a key part of what Rockwell, Siemens, and so on are supplying to their customers. And I think this comes back to the ecosystem discussion you were having shortly before this talk. The industrial IoT world runs on ecosystems, and it's intrinsic to how we serve customers. And so I do think the telcos are going to have to become good ecosystem players with people like Rockwell, Honeywell, and Siemens. That's quite an investment. They're going to need to work hard to earn their place in those ecosystems. But I think, one good news is that people like Honeywell are in a good position to make some of that international complexity go away. And so, the different country telco edge services could be components of what they offer, and somehow Honeywell might manage it so that the customer only has one management console and things can happen across telco edges in different countries. But there's quite a lot of work to get there. So I think this is a non-trivial question.
Okay, and another question I was wondering that is linked to that really, is you talked earlier on in your presentation about the fact that until COVID struck, industrial IoT was making good progress, and then the brakes were slammed on because of the dramatic change it brought about. And so now on that list you showed, Edge and IoT were at the bottom, and I'm just wondering what or when do you think will catapult it back up the agenda? Do you think it's a temporary? And how temporary?
First thing, it was only at the bottom because I cut the list off at 10. It was 10th on the list. The list was actually longer than that. So it's not at the bottom. It's still important. It just was overtaken by coping strategies for everybody to work at home, and the collaboration and the cloud sharing and even cloud operations of factory data and so on. In order to survive at all, we had to do those things. And so they moved up the priority list. I think, we're now starting to get to the stage where those are working. We've basically done those. So we can't kind of check them off yet. They're still very, very important. But I think there's room for other things to start to come back up the priority list from about now, because we've basically got the hang of working under pandemic conditions. What I think is really interesting is that the uncertainty now, will we have to go in and out of lockdowns in future with new strains of the virus and so on? So, under those conditions, I think that the need for IoT, things like remote monitoring of machines, is it still working as it should when I'm not able to send a person in to check? That becomes a really important question for people who run factories or warehouses or buildings or anything really. The need is very, very strong. It's just that the priority was shunted by the coping with the emergency conditions that we had. But I think from now on, it will start to come back up the list.
Okay, so I'm just going to ask you one more question, and please can you answer briefly, because we're running out of time, which is always annoying, but it's the nature of things. And this is, how can IoT software platforms like Cumulosity and ThingWorks help telcos productize and monetize industrial IoT?
Okay, so two-part answer. One is that for people who are already quite big on IoT, like some of the big industrials, they've made those choices. And so you kind of have to work with the choices they've made, because you can't, if they're using ThingWorks, you're not going to be able to dislodge it. It's too intrinsic to their operations now. And so you're going to have to work with those to get your edge computing in. The other part is companies, and there's an awful lot of smaller and mid-sized companies for whom this is true, companies who haven't got going with IoT. Now, you may be able to use one of those platforms as a telco to build into your own package systems that you are then selling to those guys. And what's interesting about the smaller and medium-sized part of the market is that the really big players are not very good at serving those guys because they're too small. And the telcos have much better reach and relationships with those people than the big cloud players or the big platform players. And so I think the telcos have a really important part to play, even if it's only as a distribution channel, but actually it could be much more than that, in serving smaller and mid-sized businesses in their territories.
Of which there are an awful lot in Europe. Martin, thank you very much indeed for a great presentation. We're going to send you the questions we couldn't get to offline, if that's okay. Thank you very much.
Thank you very much indeed.